My name is Jared. I'm a developer evangelist at a company called Galvanize. So what we do is we build community around data science and web development. We have a data science training program at Galvanize, and if you have any questions about that program, I'm happy to talk about it after our panel. And we're just going to go round robin now, and each of us are going to introduce ourselves. So go ahead.
I'm Josh Schwartz. I'm the head of product engineering and data science at Chartbeat. How much intro do you want? Do you want the one line or the?
Give me like a minute.
Great. All right. I can do a minute. So Chartbeat is an analytics product focused on doing web analytics for media companies. So if you're a major media company in the world, a New York Times, New York Magazine, CNN, folks like that, you're using Chartbeat every day to understand what stories to write about, how those stories are resonating in the world, and how to promote them around various channels.
Thank you.
Hi, my name is Nick Shamandi. I lead the data science team at Lyft. Hopefully you guys know what Lyft is already. There are some coupons that you can have access to if you'd like. I studied statistics in grad school, and then I worked at Google for 8 years or so. Hopefully you all know what Google is as well, so I don't need to go to that one. So I learned a ton of stuff there and trying to apply it at Lyft now and make everybody's experience better.
Hi, everybody. I'm Jonathan Lenahan. I'm the VP of Science and Technology at PlaceIQ. PlaceIQ is we're building a geospatial analytics platform. The main vertical that we're principally monetizing right now is mobile advertising. I mean, in New York City, it's fairly typical. In terms of my background, I have a PhD in physics. I graduated in 2002, and I've worked in industry since 2003. I worked in finance for a long time, and I joined PlaceIQ about 5 years ago now. I was one of the very early employees there. I think, and one of my passions actually is helping people make the transition from principally academics into industry. And so what I found when I was making the transition myself, there wasn't a whole lot of support inside the academic community to do that, and it's sort of a hobby of mine to help people with that. So I'm very excited to be on this today.
Thank you, guys. Let's give them a round of applause for taking time out of their day to be here. So as I mentioned, we'll have to talk after, by the way, because Galvanize trains data scientists, so we should.
Oh, very good.
We should chat about helping people make the transition. But as I mentioned, my name is Jared. I'd like to get to know the audience a little bit better, so I always like to ask a couple questions of the audience before we begin, so we all know who's in the audience, who we're addressing today. Who here is a data scientist? Raise your hand, please. Okay, awesome. Who here is currently a data engineer? Raise your hand. Okay. Who is currently finishing up a program, whether it be a bachelor's degree or a master's degree in some kind of STEM field? Okay, we have a few in the audience. Who here is working full-time but not as a data analyst, or sorry, not as a data scientist or as a data engineer, maybe something else? Awesome, cool. It's nice widespread. Well, we're going to jump right in. So I'm going to ask a very basic but very loaded question of our panelists. How do you define data scientist versus data engineer?
It's a great question. So at Chartbeat, being a data company, we don't have a formal role called data engineer. All of our backend engineers are focused on making data infrastructure. We have folks who work on different products, but every product and everybody's work is somehow data related. Similarly, we also on the data science side don't have folks who are focused on things like visualization, because everything that we do as part of the product is visualization. So every front-end engineer is thinking about the data viz side. So for us, the real question is, what's the role of a data scientist versus the role of an engineer, or for that matter, a product person? What I tend to think of in the analytics world is a data scientist is a person who's kind of marrying those three dimensions. So a data scientist is the representative of the data in the product, right? So they're the person who is coming up with new ideas and algorithms, ways to use the data, and also sort of on the back end saying, these are systems that we need that either I'm implementing myself or I'm asking folks to implement with me to collect new data, to store it in new ways, to build algorithms on top of it, and so on. So for us, it really is the data scientist role is really kind of sitting in the middle. In some ways, almost similar to what a product person's role is, with a very different set of concerns.
I can sort of describe how it works at Lyft, which is probably not the only functioning model, but and Prashant, who's our head of data platform, is in the audience, so he'll throw something at me if I get this wrong. But the way I kind of see it is that the data engineers are mainly responsible for like the reliability, correctness, and timeliness of the data. The data scientists are more responsible for taking that data and using it to solve business problems. And then there's some shared responsibilities. So I think like the kind of data model and the semantics of the data structures are, to me, a shared responsibility because you can't build that in a silo on either side because it usually doesn't work. So that's sort of how it works at Lyft.
Yeah, so I would say that at place like you, it's very similar. I mean, in the sense that at the level of a title, there is a distinction, but in terms of the skill set, I mean, it's a very broad spectrum. So we have maybe one or two engineers who really focus on front end, but largely I would say the rest of the engineering team, probably about 20 to 25 people. I mean, I think I would characterize them as certainly data engineers. And then I would say that about 1/3 of them could sub in at any other company as a data scientist. And on the data science side, I would say about half of them could also sub in at any other company as a data engineer. And so, I mean, a place like you, we fully expect the data science team to be able, with at least some help, to push code into production. And so I think it really is a spectrum, and it depends on the problem that we're solving. Now we're starting to get into the business of licensing software as well. And so there are a whole other set of skills that are required to enter the enterprise software business. And there we do have people who are, I mean, I think very dedicated traditional full stack engineers that I don't think you could sub into the role of a data scientist, but that's new for us, I would say.
Thank you. For the attendees in the audience who are currently, we had kind of a wide distribution of hand raise earlier. For the attendees who are looking to transition to becoming a data scientist or to becoming a data engineer, what advice would you give them?
So from my perspective, I think the fundamental skill that's overlooked very early in the process is having a very solid engineering background, and I don't think that means that you necessarily need to have the skills that a full stack engineer would have 5 years on the job, but having familiarity with the software development lifecycle, being able to speak cogently about best practices in Python development or Java development, I think is extremely important. And I mean, when I talk to people, particularly in fields like physics, who want to make a transition, this is something that I think is overlooked tremendously by them when they're looking for jobs. And I think this is usually because they spend 6 or 7 years writing code, but they don't really have a good sense for what modern best practices are in software engineering. So I do think that the data science training programs are extremely valuable, but I think almost as valuable any way that you can, become familiar with modern software engineering practices.
Yeah, I couldn't agree more with that. I mean, we expect on the data science side, a data scientist within 6 months of working at Chirpy should be pushing code to production on the regular and able to dig into a database, design a new database, dig into API servers, design new API servers, and so on. And so that process of learning is often kind of a shock, especially when somebody's coming straight out of a PhD program or another academic program, and sort of readying yourself. First of all, understanding that's what the job is, right? And I think you're hearing that in more and more places. That really is, being able to ship your own stuff is really important. So kind of preparing for that, both sort of mentally and also having the skills is a huge thing. I think your PhD in physics, having worked on a lot of sort of messy scripts, is a great example that probably every data scientist hiring has dealt with, where you have somebody who's probably developed a lot of bad habits, and they come in and you can often do sort of more poorly in an interview process than you actually should, because you've developed sort of quirky software engineering habits by working on code that there's no reviewer on, that after you publish your paper, nobody's ever going to look at again, and so on.
Yeah, I think I'd add a skill that's kind of complementary to the ones you guys discussed, and that is sort of getting your hands dirty with data, with real data, and trying to answer questions that are actually really relevant. So there are tons of free data sets out there. There are competitions. There are many things you can dive into. So if you have the time, I think that's a great way to learn how to problem solve. And in our interviews, we test that problem solving ability. How can you? So there's a term that Diane Lambert from Google coined recently, which is how do you think with data? And I think that's a skill that we really look for. And you only sort of acquire that skill by just getting your hands dirty.
That's a really good point, Nick. So what are some of your favorite ways for the audience to practice and get that experience? So you mentioned Kaggle. There's a lot of open source projects out there. Do you have any particular favorite projects that you recommend people get involved with? I was just chatting with Continuum Analytics in Austin last week, and they were telling me about some of their favorite open source projects. I'm curious, what are yours, and what do you recommend the audience check out to get more software engineering experience?
So in terms of data sets, one that we use a lot, and this is a very transportation-specific one, is the New York City taxi data. So that's a very rich set of data that we like to play around with.
Awesome. Do you guys have any recommendations?
Yes. So I mean, just because of the domain that we're in, I mean, we use the New York City set a lot for for small projects when you're late stage in the interview process. And I think the importance of getting your hands dirty with data is that it's extremely important that you develop a facility or intuition about how to work with data. And so this is something that only comes with a lot of practice. And so in the same way that if you're in a physics PhD program, you tend to develop a sort of intuition, physical intuition that you aren't necessarily that you don't necessarily have when you're born, but in the same way, just doing small experiments with real data, there's no substitute for that. And sorry.
Oh no, go, yeah.
Yeah, and so just in terms of getting access to interesting sets of data that solve real-world problems, the Kaggle competitions, I don't think you can beat that. So.
And by the way, you can start small. I mean, there's data sets in R that you can just play around with first, and then sort of keep challenging yourself with bigger and bigger and more challenging problems.
I also think, for folks who are sort of ready to dive into problems, a great thing that I think is also a good for the world thing to plug is there's an organization called DataEngConf that does data science volunteering. You work with a set of nonprofits and sort of volunteer your time. It's a great opportunity to both do important work in the world and also pick up skills. And the set of people who work on DataEngConf projects is a pretty awesome group. So it's a great way to meet folks and understand what's happening in the industry.
So Jonathan, you mentioned data science programs earlier. What are the advantages and disadvantages that you three see in students who are coming out of data science programs, whether it be a 3-month boot camp or whether it be a year-long master's degree? What are some of the advantages and disadvantages that you see? And then when you recognize potential and you decide to pull the trigger and hire one of those candidates, how do you help them overcome the disadvantages?
So I think as an advantage of thinking specifically about sort of accelerator programs that take people often from academia and into data science, an advantage is that there's often a small, like we were talking about with engineering knowledge, there's often a small delta between the set of stuff that a new grad PhD knows and the set of stuff that will get them hired at the job that they want. And often you don't really know how to talk about your work, you don't really know how to do a coding interview and things like that will block you from ending up where you want to be. But with 2 or 3 months, you can be positioned to be, to just be a much, much, much stronger candidate. And I think those programs can pay huge dividends. And also in terms of connections, we've hired folks out of those programs who we just never would have come across and would have never come across us otherwise. The one fear that I have with some of these programs is they often can lead people to be very buzzwordy. right? So I'll see folks, whose resume says, I am an expert in scikit-learn, I'm an expert in MongoDB, I'm an expert in, Redshift, I'm an expert in Spark, and you're like, are you really, are you actually an expert in those, or did you, sort of import sklearn, run a couple functions, and so on. And so I think the key is that when we're interviewing folks, we're looking for expertise, right? So more than a long list of things that you've dabbled in, I want to see that you're really good at something. If that something is physics, it's fine, right? But I want to know that you really know that stuff. And so I think in thinking about those programs, think about them as ways to learn the industry and ways to learn a bit of software. But I think make sure that you're not just sort of thinking about a list of small skills to pick up.
Yeah, I think I was thinking along similar lines. It's kind of a bit of a breadth versus depth argument. I think one positive thing is that, and this is related to what you said, that because these things are relatively short, you end up learning about the most kind of popular methods that startups and small tech companies are using today, which is, I think, if you go through the sort of PhD and then go work at a big company for a number of years like I did, you sort of miss out on that. You're not as up to date on sort of the newer technologies. Like in grad school, I used R and MATLAB, and then at Google, they have their own way of doing things with a very limited set of different tools. And when I left Google, I discovered all these other things that were out there that sort of had been built in-house at Google in a very different way. And so I think it's basically exposure to those things that you're getting in some of these bootcamp type programs. But again, I think the drawback is you may not have, depending, of course, on your background. So I think the drawbacks depend on what you did before. But you may not have as much of a depth in terms of the underlying math behind some of the topics you're learning about. And so that would be, that's the one concern we sometimes get with candidates coming out of those programs.
Yeah, I would say that so I'm a very large advocate of the programs themselves, and I think to echo what Josh said, I mean, there really is for people to go into these programs, there really is a very small delta between the skills that you already have and the skills that will get you through the interview process. And so, I mean, so if you take a very sort of jaundiced view of the interview process, I mean, the people who are, no matter how, even with the best of intentions, the interview process is set up to screen up people as quickly as possible. So if there's even a single thing on your resume that somebody finds annoying, you're already at a very large disadvantage. And so I think the programs are extremely useful for networking, for getting you in front of people, for helping you with the interview process, and it definitely level sets these sort of skills that you need to pass interview. And so, I mean, I think one drawback I would say is people who come out of the program, the resumes, aside from what you did before, they tend to be a bit more undifferentiated in the sense that like everybody writes down scikit-learn and random forest, and so that's not a real differentiator. So I would also say another reason why I like the programs is that people who typically enter them are extremely motivated to make a switch in life, and so they definitely want to go into a different profession. And so, I mean, that already I think is a huge plus when you're interviewing somebody.
Yeah, just to add on to what you said, I was sort of laughing to myself as you talked about the undifferentiation. When you're hiring, it's a very different perspective than when you're job seeking. And one funny thing about interacting with folks coming out of programs is that there's a big batch of folks coming out of the program at the same time, which means that you're looking at a stack of 30 PhDs from elite universities, master's degrees from elite universities, who all then list the same 10 data science skills, and are all super motivated people who decided to take the time and go through this program. And it makes hiring really hard, right? And it makes it really, you're actually ironically, by going through the program, you've put yourself in a more difficult position than if you applied one-off. Almost anybody who goes through one of these programs, if they just emailed in their resume, I would be like, wow, this is awesome. We got to get this person in today. But when you're in that stack of 30, I feel like I have to call down to 5, and that makes it difficult. So I think, thinking about, how you're pitching yourself coming out of it, and rather than just sort of relying on the program, picking which companies that are partnering with the program that would I actually be passionate about working at, and like making that very, very, very clear to those companies is really important.
I'm going to go out of order. I have this sheet here that's kind of it's helping me out in asking these questions, but I was going to go in a particular order, and I have to deviate now because you said some really awesome stuff. And to follow up on what you said, how do I decide which path to take in terms of data science versus data engineering? And then let's say I'm already committed to a path. We have a bunch of people in the room who are already data scientists or already data engineers, or maybe they're recent graduates from a master's program or a boot camp. How do I decide what to specialize in? So how do I differentiate myself? So am I really good at visualization, storytelling? Am I a data scientist that is an excellent programmer? Or am I an excellent predictive modeler? Like, what's my secret sauce? And how do I choose that? How do I find it?
That's some profound life advice. To me, the paths are so different that it's almost, I think it's probably obvious to a person considering the paths, right? So, being a data scientist, like being any other scientist, is profoundly frustrating and depressing in many ways, right? Like most things that you do won't work, right? Like most, you have to be just like, being in grad school or doing anything, you try things, they don't work. You try other things, they don't work. You spend a month on a project, it goes nowhere. Nobody likes your algorithm. You can't figure out how to do what you were trying to do. And that is a extremely rewarding and stimulating process, but is like doing science, right? And engineering, I think, I happen to be really excited about both, but engineering actually, the problems are hard, but you sort of have this moment where you're like, I know I can solve this, and you get that, that payoff where, your code compiles and you're like, woohoo! And that doesn't happen in data science. So I think which of those spectrums you live on, I think is probably clear, but to me that's the real difference.
Yeah, I would agree with that. I think even within data science, which is what I can speak to more, it's a little bit unnatural to say like, hey, I want to be a data scientist. Now let me figure out what I want to specialize in. I think it usually happens the other way around. You always loved math, and then you say, hey, I can apply this and become a data scientist. Or you always liked, writing algorithms to optimize things, or whatever it might be. So I think of data science is not a perfect analogy, but a little bit like social science, where you don't just say like, oh, I want to be a social scientist. Now what should I work on? You actually say, oh, I'm passionate about linguistics or sociology, and then later on you identify yourself as a social scientist.
Yeah. I myself I'm very drawn to both of them, but just looking at the people in my company and people I've talked to, you really want to think about, what causes you that moment of elation. Because at some point, even if your job is frustrating and you hate it, it is going to have to be, I'm sorry, not that you hate it, but there are times that you will. But in order for it to be rewarding, you have to have those moments of elation. And so if discovering something interesting, really gives you that feeling, then I would stray towards the data science path. If what you're interested in is building large systems and you're extremely passionate about having something of great complexity running all the time, 24 hours a day, and you really like monitoring, which sounds crazy, but some people do, then I would go the route of the data engineer.
So I have a question from a speaker that I was speaking to earlier today. It's Peter Lenz, who was recently in this room, and now he's across the way. Oh, there he is in the back. He finished up his office hours. So Peter asked, let's see here. What advice do you have for people who do not come from the traditional stats and computer science background, but have found themselves at a job where they are called a data scientist? And to give you some insight onto Peter's background, he was, I believe, a geographer, is that right? But he taught himself a lot of the skills along the way.
Yeah, so I'd say if you find yourself in that position, chances are you do have some relevant skills, either, and passion is almost a skill in that sense, right? So And if you're lucky enough to be in an environment where you're working with other data scientists, then I think it's a great opportunity to learn from them and maybe teach them something as well. I think that can work really well.
Yeah, I mean, I would say that that if you've already been in the industry for a few years and you've found yourself into that role, I mean, like you said, I think it's because you are a person who naturally acquires new skills and is comfortable with ambiguity in role, because that's essentially how you random walk there. And so I mean, I certainly don't see a problem with that. And if I'm interviewing a candidate who has 5 or 10 years of industry experience but started off as a history major, I mean, it's completely irrelevant to me.
If we zoom out and we look at the entire landscape and look at data engineering and data science, what skills are you currently seeing a shortage of amongst candidates and amongst even data scientists and data engineers that work at your companies? Like, where are people weak, or where is there a shortage of skill?
So this isn't a hard skill, but I think the hardest thing for most data scientists to get to is being able to do product thinking, right? So in the end, if you're working at a technology company as a data scientist, the output, you may be doing sort of internal analysis where the product is sort of your analysis, or you may be working on a product directly. But actually, I mean, this sounds sort of trite to say, but like, your job is coming up with problems and then solving them, and that's very different than in an academic setting. And coming up with like the sense of taste for what makes an interesting problem and also a tractable problem takes a really, really, really long time, and is fairly domain specific, and that's the thing that I think is hardest to get, but is the most valuable when you have.
I would add, I think maybe not a skill that's necessarily missing yet, but that's a little bit underrated relative to skills that are being taught in a lot of these programs, and that is inference. So there's a lot of focus now on sort of prediction problems and machine learning and black box type stuff, which I think has a place in many problems. But there's a lot of nuance around, even when you're framing a problem or coming up with an idea and understanding the data. I think causal inference in particular is something that's pretty underrated, and we don't see a lot of people coming in with exposure to that, or if they do, they have very like traditional economics or statistics backgrounds and maybe underpowered in terms of computing and machine learning. So I think sort of merging those more is going to be a big bet for the future. And even extending to things like A/B testing. I don't know if anybody saw the talk by, I think Sergey was his name. We're facing many of these same challenges where something that's kind of taken for granted is actually way more nuanced than you might think, and requires some ability to do inference and not simply just power through.
So I think those are both wonderful answers. To those two, I would also add that estimation is a skill that I think is that people need to hone. So being comfortable with giving order of magnitude estimates for things is so for people who come from some specific fields, this just through the course of your academic work is sort of natural. For other people, just giving an answer to somebody within a factor of 2 or 5, they become extremely uncomfortable with that. And so I would say that you can get very far without having to do a whole lot of work in computation in certain circumstances, just being comfortable making estimates based upon what you already know. And so, I mean, I know for sure at Place IQ, I mean, we've wasted tons and tons of computational cycles and storage when a simple back of the envelope calculation would have done. And so I think I'd like to elaborate a bit on Josh's point. When I came to Place IQ, I had no idea what a product manager did. I had no sense at all. I mean, I worked in physics, I worked in finance, and this notion did not exist. And so product thinking, and in particular, even if you aren't doing a lot of storytelling, being able to talk to people on the business side is extremely important, and understanding what product management is or product development is an important skill. And I think a good test is whether or not you think you can explain what a product person does.
That's interesting. Yeah, we try to get a sense for whether the candidate has good intuition for the product and what the constraints of the business are in terms of coming up with a solution. We used to have a product manager on most of our interview loops. Unfortunately, we had to stop that because he literally voted no to every single candidate.
So we have product thinking and product taste. We have inference and estimation. How can we, all of us in this room, and we as a data community, how can we decrease this shortage? And how can we help decrease the shortage of skills?
It's a really hard question because those are all sort of softer.
Yeah.
I mean, I think for us, one of the keys is having a diverse team, and that's along many axes, including academic diversity. So for us, it works really well because we have a diverse spectrum of problems to solve, from optimization to things like inference, prediction, all kinds of stuff. And so we just naturally get a lot of different people applying, and therefore different points of view. So I think for us, we can teach each other the skills that are the gaps that may be there.
So I had one other question from Peter. I don't know if is Peter still here? Is he gone? He's outside. Maybe I'll ask this one in a bit when he comes back in. So another question that I had is, let's see. So as you start to consider promotions internally for your data scientists and data engineers, I guess what are the common signs that somebody on your team is ready for the next level? What differentiates a B data scientist or data engineer from the A scientist or A engineer? And furthermore, what is that next level?
For us, I mean, what's true on the data science side is also true on the engineering side. That moving up levels of seniority is about being comfortable dealing with different amounts of abstraction, right? So a more junior person, you can sort of give a concrete problem. Okay, implement A/B testing for this thing, and the person can do it. They can code up the relevant math and write the right code. But the problem statement is pretty defined. A more senior person, you can give an abstract problem, right? We want to solve this thing, and they can decide, okay, A/B testing is the right methodology. Are we doing a split test, or are we doing a bandit? Things like that. And as you move up the stack more, the person can define the problem, right? Oh, I think that we should do this feature, and I think we should A/B test it, and here's the A/B testing algorithm. So I mean that sort of moving up the level of abstraction, I think really in almost all jobs is what moving up the stack of seniority looks like. For data scientists, what that generally means is that people are more comfortable identifying problems. So a new grad data scientist, we might say implement this specific thing, and a very senior data scientist is just going to be identifying the problems that they should work on and then solving them.
Yeah, I would agree with all those things. Also, I mean, for us, I think the number one thing we look at is impact, and that can mean different things in different situations. So for some people, they just want to be an individual contributor and have their head down, and maybe they're developing new methodology that unlocks big gains. So that's one way to have impact. Maybe they're becoming a tech lead and sort of magnifying their impact by mentoring others and pushing others to do new things. Maybe they're just coming up with new ideas, and instead of sitting quietly in a corner with this idea or telling their 3 friends about it, they're actually championing this idea to the point where it gets prioritized on a roadmap and actually ships. So I think there are different ways of measuring impact, and different people maybe tend towards different ways of doing it, but that's for us the single biggest bucket, I would say.
Yeah, I would say the only thing that I would add to those is I think the level up happens for me when someone starts to really gain domain expertise or knowledge in the industry that you're working in. And so, I mean, just to take myself as an example, so I mean, I never thought, when I was younger that I would be working in mobile advertising. It just seemed like, why would I ever want to do that, and it turns out it's something that I'm very fascinated by now, and so I think when you're making a shift to industry, it's almost always the case that you'll be working in an industry that you never thought was interesting before you went into it, and so there are very specific things about each industry that you absolutely have to know to make impactful products for your company. And just to give a concrete example, a lot of people when they first start a place like you, they think that data is data, and the data generation process itself isn't that important. But I think a lot of the gains that we've actually made inside are really understanding in detail how hybrid positioning works in location services on your phone. And so that's very, very specific domain knowledge that I wouldn't think would have anything to do with mobile advertising, but it turns out to be extremely important. And so I think the people who have accelerated very rapidly at my company are those who've really taken the time to get a very deep knowledge about the industry and how the data is actually generated.
Thank you. The next question is from an attendee from earlier today. I forgot their name, but I'll see you later today. The question was, how important is it for a data scientist to be able to code, and how well should they be able to code? And then, how difficult is it to teach scientists to engineer?
I think it's super important. I mean, its importance can't be understated. If somebody can't ship code, they can't do their job. At least, for us. I don't expect a data scientist interviewing to understand real heavy-duty software engineering. I don't understand them to have worked with Kafka or databases, any of the systems that we use for data processing. But I certainly expect them to be able to write well-formatted, carefully thought out, algorithmically signed code. It's really, really important. And they have to like doing it. Like, there are times when you talk to folks who sort of view like code as a thing that you have to do. I really like doing pencil and paper math or lab work, but I can write code if I need to. And you want somebody who actually is excited about building, because it's kind of what the job is.
Yeah, I think, I agree at Lyft as well, being able to code is necessary. There's obviously different levels of that. So I think one thing to keep in mind is that data science means different things at different companies, and so I don't know that the requirements are, that stringent everywhere. For us, I think having familiarity with SQL is important. Being able to write scripts is obviously really useful. And then for most people coming in, knowing object-oriented programming at some level, because they're going to be expected to at least ramp up in that in order to write production code. So having it from the get-go is obviously a bonus. In terms of teaching data scientists how to be engineer or be more engineering-oriented, I'm not really an expert on that, but I would say that for me it was just working closely with engineers really helped me. That first code review that I sent to a really senior engineer was slightly traumatic experience, but also lessons that I never forgot. And so I think encouraging, especially junior data scientists, to work closely with experienced engineers or other data scientists who are strong coders is really valuable.
Yeah, I agree with that. I think it's extremely important. There certainly are roles where the engineering aspect is not as important, but just in terms of finding a job in the industry, it's going to be much easier if you can write clean, well formatted code. I think in terms of having to know modern data infrastructure, Kafka, Spark, etc. If you aren't already working in the industry, I wouldn't spend much time on that. It's hard to learn that on your own, and that's something you can certainly learn on the job. But the ability to write code and more importantly, to like to write code, I think is essential. And there are roles that won't require that, but they're becoming fewer and fewer.
Well, Peter's out there talking, so I'm just going to ask his question. He can watch the video later. So Peter's question was from Peter Lenz again. There's kind of an elephant in the room in our industry. We all work in the technology industry, and it tends to be slightly ageist, right? So here's a scenario. I'm a 30 to 35-year-old data scientist. Sexiest job of the century. I don't know if anybody's benefited from that title, the sexiest job in the world. But I mean, try it at maybe you'll get a free gym membership or a free beer sometime. I'm the hotness. I'm highly in demand. I'm a young gun. I'm the hotness, right? The data scientists and the data engineers in the room, you're the hotness. What do I need to learn or do to be relevant in 10 years? And does a data scientist or a data engineer have a shelf life?
Oh, I don't think so, and I certainly hope not. I don't know. I don't know. I mean, just make cool stuff, right? I mean, I don't know. I mean, I think that I certainly, am as excited about talking to I'm more excited about talking to somebody who's been an engineer for 25 years and has been around the block than I am about a new grad. So yeah, I mean, if you're doing good work, right now is obviously a crazy time for technology in general, but if you're building great stuff, I think you don't have anything to worry about for a long, long time.
Yeah, I agree. It's a little hard to take that quote seriously if you know Halvarian, who was the one who said it. I certainly hope that there's no shelf life. I think, if you've studied these disciplines, you're probably someone who is happy to learn new things and evolve your thinking over time. And I think, there's no substitute for experience when it comes to the core problems that keep coming up over and over, maybe in a slightly different guise. But I think the more experience you have, the more equipped you are to solve new problems too.
Yeah, so I mean, I certainly don't think there's a shelf life if you're willing to learn new skills. And so if you work in technology, that's something that you have to do over and over and over again. And so, if you have that capability, then I don't think there's a problem at all. I mean, in terms of ageism, I think there may be a small bias, but it's not. It's not huge. I mean, I'm the third. My company is 150 people. I'm the third oldest person there, and I'm only 42. And I think if I hadn't started there so early, coming in may have been a little awkward when everybody is 25 and 27. But I mean, it's not. But it does nothing to affect the quality of your work at all. So.
Thank you, guys. Is there a glass ceiling for data scientists or data engineers who don't want to manage, or like you mentioned earlier, who are not comfortable with those levels of abstraction? Or who are on a team where there just aren't management positions open? So I'm on a team of 20. We have a director. Where do I go from here?
Yeah, I think it depends on the company, and if you're joining, if you're joining an early stage company, sort of the sky is the limit for data scientists, right? My own experience as a data scientist, I started at Chartbeat as a data scientist. I thought my job was to sit in the corner and write algorithms, and I went on as we went from a data science team of 1 to 2 to 5 to 9. I went on to lead that team, went on to lead the engineering team, went on to lead the product team. If you're doing impactful stuff and you join early, there's a ton of potential to grow. At more mature companies, the standard setup is that you have individual contributor tracks and manager tracks. Certainly, if you're joining a place, you should look for a place that has an individual contributor track that actually is real. But I think there's absolutely there's so much good work to be done in the data science world that I don't feel like there's a limiter in terms of requiring people to move into management. And I actually think, despite having done it, I think in many ways staying an individual contributor for as long as possible is a good move. Once you move into management and your life becomes meetings, you stop learning about hard technical skills at least. And picking up technical skills for as long as you can is both way more fun and rewarding, and also pays off in the long term.
Yeah, I would agree. I think definitely at Lyft and Google and other places, there's certainly an individual contributor track that goes sky high. I would say even if you can be protected from people management, I think one thing you probably can't get away from is leadership of some sort, and usually that's technical leadership. And I think the reason is that if you're a level 10 on whatever scale data scientist, but not doing any technical leadership, then it's kind of a waste of your skills because you only have 24 hours in a day to do the amazing work you're doing, and you can amplify that a lot by mentoring 3 or 4 or 5 other people. So I think technical leadership though is still rewarding in kind of the same way that being an individual technical contributor is.
Yeah, I mean, I would agree with that. I would say that, I mean, in terms of executive level roles, I mean, I don't think that they really exist except in the level of the CTO. I mean, most chief data scientists are non-executive positions, but I don't really think that's what we're thinking about here. I mean, in terms of salary, I certainly don't think there's a glass ceiling, and on the technical leadership side, I mean, I think we've had very similar tracks wherein, I mean, when I started at a place like you, I was the only data scientist there. I had no interest in doing any sort of management or technical leadership, and then I took over that team and then became VP of engineering. Now I'm working in product. So, I mean, as long as you're willing to learn new skills, either on the IC track or in the technical leadership track, I really don't think there's anything holding you back. And in particular, if you're coming from the data side, I mean, I think you're at a much greater advantage to take over or lead entire components of the product development organization, not just engineering or data science.
Quick pulse check. How are we doing on time? We're good? We've got 5 minutes? Okay. Well, let's give our panelists a round of applause again. I'd like to use our last 5 minutes for Q&A, and I'll be the guy who runs around the room and hands out the mic. So let's kick it off. You first? Okay.
So would you say that there's, would you say that there's a limit in those who have not gotten like a very thorough mathematical background from a higher institution, a limit of how much data science they can actually understand? Or do you think they can pick that up in production?
It's such an interesting question. It's a very hard question to answer. Most successful data scientists have very serious mathematical educations. On the other hand, the irony is that most applied data science doesn't involve sophisticated mathematics. It involves, reasoning about numbers, but not, bleeding edge, optimization or machine learning algorithms. And so it's not at all clear why it's the case. There's this, family of problems that I sort of call problems that you shouldn't need a PhD to solve, but somehow you do. And so there's absolutely no reason why a motivated, creative, quantitatively inclined but not quantitatively educated person couldn't learn those skills. But it is, I think being frank, it is hard. And most people who do it have CS degrees, physics degrees, linguistics degrees, neuroscience degrees, and so on.
Yeah, I think more than anything, I agree with Josh. It's kind of like a signal that the person has the ability to get deep into a quantitative problem, but it's not necessarily the thing that causes them to have success. Like I was talking with my colleague yesterday, when's the last time we used measure theory in one of our data science problems, right? It doesn't really happen. But I think
for yourself.
Yeah. So I think it can be a signal, but it's not necessarily a requirement. We hired someone recently who, had a sort of a biological sciences PhD. Later on, did a galvanized program, I think, and then interviewed extremely well because she was able to just reason about the problems and the data in a very organized way and was able to come up with reasonable solutions within the business constraints and all those things. And so it's definitely not a prerequisite.
Yeah, I think having strong quantitative reasoning skills and intuition is really all that matters. But I mean, I think having a degree like that, I mean, it is it's a predictor, but I mean, it's not something that I would dismiss anybody out of hand. So.
The one thing that I think grad school gets a person used to what I mentioned earlier about failure, grad school gets a person very used to failure and to dealing with uncertainty, and it's often the biggest hurdle. We've certainly hired folks straight out of college or out of industry jobs, and getting into data science and getting used to failure and uncertainty is often the biggest thing that people need to come to terms with for at least their first 6 months or a year.
Yeah, and I would say there are like some basic skills that we look for in candidates that you don't need a PhD in order to possess, but things that, basic mathematical skills that you should have, understanding probability, understanding variance, those kinds of things. So I think that's important, but those are not things that require, 5 years of studying.
Question over here. Okay. I think we've got time for like 2 more. We can squeeze them in.
So we talked a lot about data scientists and data engineers today. I have a 2-part question. Instead of talking about the individual contributor or the scientist, how do you find success as a technical lead on a data-centric team? And what are those qualities that you need to foster?
Matt is asking the question as a technical lead on a data-oriented team at Chirpy. So I'll let someone else take that.
What do you mean by data-oriented team? Is that like an engineering team that happens to have data science problems? Or?
Yeah, it could be, I kind of want to leave it a little broad, but maybe perhaps a product that shows data, or probably in your case, something that like leverages data internally, using it to make business decisions or something like that.
Yeah, so I think a lot of the themes we've talked about, right? So like balancing the business constraints with the mathematical framing, being able to convince a product manager that a solution is the right way to go, being able to work with the software engineers to make sure the interfaces are such that this thing can actually work, and also collaborating with other data scientists, because typically at Lyft at least there are usually at least 2 to 3 data scientists working on a particular team, and so collaborating, playing off each other, iterating on each other's ideas. So having a collaborative spirit and a very collegial kind of approach is pretty important.
I think the only thing I would add is the ability to speak multiple languages, and it's been my experience that people who are very deep in engineering are incentivized by some class of things, and on the data science side, it's another class of things at the extremes. And so really understanding what motivates people and incentivizes them, I think is important. That's a mistake that I've made many times in the past.
I have a question, and that's about balancing research side of a data science and the product part of a data science, engineering part of a data science. So if you're working at a tech startup and your resources are limited, you're not like Google that you can spin up 1,000 machines that run one SVD or matrix factorization in a matter of seconds. You would have to come up with new algorithms that are computationally efficient, and they're on the cusp of the research. So how do you balance that time between putting a lot of research time and actually coming up with something that works?
Yeah, I'll take. So I think if you're working if you're working as a data scientist at a company that makes a product that isn't directly what your research is, and it's not a huge company, you're using mostly off-the-shelf stuff, right? So you may be applying, you're choosing what algorithms to use. You may be implementing things by themselves, but for the most part, you're using off-the-shelf databases, and you're using you're using libraries that manage things. So I think especially for kind of folks coming out of academia, it's a bit of a transition to get used to, so much of your work is sort of figuring out which algorithm to apply rather than writing new algorithms, and that's often a change. In the end, it's the result that matters. If you can solve something without coming up with a novel algorithm, you've done a better job than if you had to come up with a novel algorithm, which is exactly the opposite of incentive of if you're trying to get a paper published, and that takes some getting used to.
Yeah, I think it's actually a difficult problem and usually requires some amount of back and forth with product owners at a company. And of course, it depends on the size of the company. But even for a company like Lyft, which is not that small anymore, we still struggle with this balance. And I think it can become very tempting from a product perspective to just make incremental improvements and not think about sort of long-term research. And so we try to weigh the pros and cons of that. One example is we have this simulation infrastructure which we've built, which is actually a lot of work to build and maintain and extend for different use cases. And it's not like directly improving the product. It's only allowing us to better evaluate other things that will improve the product. And so, but I feel like our product managers are pretty accepting of the fact that this is going to take some of our time and maybe mean that a data scientist is unavailable for 2 weeks while that person is building out this simulation environment, but in the long run it's going to pay dividends. So I think it's partly about convincing the product owners that this stuff is valuable, and also about just sort of believing in it.
And I think once the product owner is convinced, it's something that I always put a finite time box around, and so and that's always like a struggle messaging that in a way that doesn't upset somebody, but that's management.